In question 1, we're asked to solve this difference equation. And we're given u0. So let's try and find a pattern here. u1, when n is 1. We're going to get u1 here is equal to a half times u0 plus 1. 1 minus 1 is 0. When n is equal to 2, we're going to get u2 is equal to a half. This will become u1, as you can see, which is up above, plus 1. So replacing u1 with a half u0 plus 1, we'll start to develop a pattern. Don't forget to bring this plus 1 down. So this is going to be a half to the power of 2 times u0 plus a half times 1 plus 1. Let's do n equal to 3, 2. Then we can write out our pattern un. When n is equal to 3, we're going to get u3 is equal to a half of u2 plus 1, which is a half of u2, which is this whole expression, a half to be squared, times u0 plus a half times 1 plus 1. So that's going to be a half to the power of 3 times u0 plus this half by this half, a half to the power of 2, looks like n minus 1 times 1 plus 1. So if we take this as our geometric sequence, we can factor out our 1. It's going to be, this is n minus 1, so if we reverse it around, we're going to have 1 times 1 plus a half to the power of 2. That's going to go all the way to a half to the power of, well, it's a 2 here, the max we have, when you're dealing with u3, so it'll be n minus 1 for our last term. So this is a geometric sequence where we can write it as Sn is going to be equal to a times 1 minus or to the power of n over 1 minus or, which will be 1 times 1 minus, the ratio is a half, over 1 minus a half. We've seen this already. When we have the half on the bottom, it's going to bring a 2 up on top. So we'll end up with a 2 here. So we're going to get 2 times 1 minus 1 over 2 to the power of n. I'm just going to multiply, well, I'll leave it actually as this. I'll multiply it out 2 minus 2 times a half to the power of n. Sorry, a half to the power of 2. So just bringing this expression down to meet it so I didn't have to write it all the time. We have a half to the power of n times u0 plus 2 minus 2 times a half. Well, actually I wrote a 2 there, it should have been n. So we're going to get u0, I think it was 100, was it? 100. So we have 100 times a half to the power of n minus twice a half to the power of n plus 2, which is going to give me 98 halves to the power of n plus 2 for this expression un. So this is solving this difference equation. And obviously the limit as n approaches infinity here is going to be 98 times 0 plus 2, which is just equal to 2. Same type of maths involved here. Given the expression, we're asked to solve this expression, or this difference equation. u0 is 32. So when n is equal to 1, we get u1 is equal to a third times u0 plus 2. When n is equal to 2, we get u2 is equal to a third times u1 . Sorry, a third times u1 plus 2. And if I replace u1 with what's above, I'll have a third times u0 plus 2 inside, and this plus 2 at the end. So that's u2 which will be a third to the power of 2, it looks like to the power of n times u0, multiplying the bracket out, plus a third, I'm going to put the power in, times to the power of 1 times 2, and then plus the 2 at the end. So let's look at n is equal to 3, and then we should be able to see the pattern. u3 will be equal to the third of u2 plus 2, which is what we have above, a third of this whole expression, a third to the power of 2 times u0 plus a third to the power of 1 times 2 plus 2. We also have the plus 2 at the end. So we're going to get a third to the power of 3 times u0 plus, I'll factor out the 2. I don't know what that bracket's doing there. I left out a third. No, that's okay. So I'm going to factor out, and I'll write them out first. A third, 2 times a third to the power of 1 plus 2. Multiply that by the third times this 2 times this third. 2, the 2 times the third, and I've left out this one here. It should be a third to the power of 2. Multiplying this one, I'm just trying to go too quick. Third to the power of 2 times 2. Just double check, a third times 2, yeah, plus 2. So if I factor out my 2 from this expression, I'm going to have a third to be squared, which is n minus 1, because we're on a u3, plus a third to the power of 1, and I'm factoring out the 2, so that would be plus 1. So reversing this expression around, 1 plus a third to the power of 1 plus all the way to a third to the power of the highest one in here is 2, so n minus 1. And I'll bring down my third to the power of 3 times u0. So converting this to un, we're going to have a third to the power of n times u0 plus 2 times this geometric expression. So let's make it into Sn and just do it up here. Sn, when we have a is equal to 1 and or is equal to a third. So we're going to have a times 1 minus or to the power of n over 1 minus or. So we imagine that this 2/3 is on the bottom here. We're going to have on top 1 minus a third to the power of n, because the 1's in front. So bringing that expression down here, the 3 ends up on top. So we're going to have 3 times 1 minus 1 over 3 to the power of n, and the 2, this 2 here, stays on the bottom and cancels with the 1 that was originally in that position. So un becomes a third to the power of n times u0 plus, multiplying it out, 3 times 1 minus 3 times a third to the power of n. So what was u0 in this case? u0 was 32. So we're going to get a third to the power of n, 32 of them, minus 3 of them, plus 3. This is un, so un becomes 29 of them. 29 times a third to the power of n, plus 3 to solve this difference equation. And the limit, we're asked to show that it reaches a limit. The limit as n approaches infinity is 29 times a third to the power of infinity, which would be such a small number, it tends to 0. So the limit as this approaches infinity will just be 3.